What's good, math family? In this video, we're going to look at how to solve different types of radical equations. We really hope you find this video helpful. Let's get started. So in the first example, we noticed that the radical is not isolated, and we have to isolate so we could solve. So we're going to subtract 5 from both sides, and this is what we're left with. Now that the radical is by itself, we could get rid of this square root by squaring it, and we're going to do the same thing on the other side. So we're left with 3x plus 4 is equal to 25, and we're going to solve like a regular equation. So after we subtract and combine, we're left with 3x is equal to 21, and then we're going to divide by 3 to get x is equal to 7. Now, anytime you solve these type of equations, you always want to check to see if the solution actually satisfies it. So we're just going to plug it back in and check. So when we simplify this, we know what's under the radical is going to be 3 times 7 plus 4. This is going to be 25. Now when we simplify, we know this is going to turn into 5 plus 5, which equals 10. So we know that x is equal to 7 is the correct solution, and it will satisfy the radical equation. In the next example, we notice that the radical 2x is not by itself. So we're going to want to add 3 on both sides as our first step. So we're left with 3 times radical 2x is equal to 12. Now we're going to divide both sides by 3 to get the radical by itself. So we're left with radical 2x is equal to 4. And now for us to repeat that same process by getting rid of the radical by squaring. So we have 2x is equal to 16. And once we solve for x by dividing, we know x is equal to 8. And when we go back and we plug this in, we know 2 times 8 is 16. The square root of 16 is 4. When we multiply that by 3, that gives us 12. And after we subtract the 3 from it, we know that this equation, 9 is going to equal 9. So this is the correct solution. Always make sure that you double check for extraneous solutions. In this example, we have to be mindful because instead of talking about square roots, we're talking about cube roots. So we're going to start this off the same way by isolating the radical. So after we add 3 on both sides, this is what we should have left. So just be mindful that this is a cube root. So when we go ahead to try to cancel out this radical, we're not taking it to the second power because it's not a square root. So we take both sides to the third power. We're left with x squared plus x plus 15 is equal to 27. So now this is just like a regular quadratic equation. So we're going to set it equal to 0. So we subtract 27 on both sides. And what we're going to have is x squared plus x minus 12 is equal to 0. So now when we factor this, we know that we're going to have x plus 4 times x minus 3 is equal to 0. So after we set our factors equal to 0, we know we're going to have x is equal to negative 4 as one possible answer, and x is equal to positive 3 as the next possible answer. So yes, in problems like this, check for the extraneous solution. So I'm going to plug in 4 first. So we have negative 4 squared and just make sure that when you substitute it back into the original equation. So we have the cube root of 16 minus 4 plus 15 minus 3 is equal to 0. So when we simplify what's under the radical, 16 minus 4 gives us 12, 12 plus 15 gives us 27, minus 3 is equal to 0. We know 27 is a perfect cube. So we simplify this to 3, write the rest of the equation, and we notice that when x is equal to negative 4, this solution will work. Now we're going to check the second answer. So we rewrite it and substitute again. So now we do the same thing. So we had the cube root of 9 plus 3 plus 15 minus 3 is equal to 0. So we know 9 plus 3 is 12. 12 plus 15 is going to give us 27. Rewrite the rest of the equation like in the previous problem, perfect cube. We simplify it to its cube root. And after we simplify, we notice that both of these answers will satisfy the radical equation. This does not always happen, but just make sure you double check so that you don't get the problem wrong. In the next example, what you may see is an equation that has two radicals. So we want to make sure that the radicals are on opposite sides of the equation, which they are. So we're going to come in here now and get rid of the radicals by squaring both sides. So on the left side, we're just left with 2x minus 5. But on the right side, we have to be mindful that we are going to FOIL. So I'm just going to use the box method real quick so that you guys can see how we get our answer. So after we FOIL, we have 1 x minus 3, radical x minus 3, I'm sorry, times radical x minus 3. And in the last box, when we multiply those two radicals by itself, it's just x minus 3 without the radical. So we fill this in now. And remember, we combine those like terms. These two are going to be considered like terms. So this is going to be 1 plus 2 times radical x minus 3. And then at the end, we're going to put plus x minus 3. Now, before we try to move anything from one side to the other, let's just clean these two like terms up. So left side stays the same. 2x minus 5 is equal to 2 times radical x minus 3 plus x minus 2. So now we're going to move things from one side to the other. So I add 2, and I'm going to subtract x at the same time. We're going to do 2 steps in one. So now we have x minus 3 is equal to 2 times radical x minus 3. So now we're back at the same step where we have to get rid of the radical so we could solve. So for us to properly do this, let's switch into green so this sticks out. We're going to go ahead and square both sides again. But you have to be mindful because on the left side, when we expand that binomial, it's going to become a trinomial because we're foiling. So we're going to have x squared minus 6x plus 9 is equal to 4 times x minus 3. The reason we didn't FOIL on the right side is because that is one expression. It's not separated by a plus or minus sign, so please don't make that mistake. So left side of the equation stays the same, but we're going to distribute on the right side to get 4x minus 12. Now for us to solve the radical equation, we subtract 4x on both sides. And what we're going to get is x squared minus 10x plus 9 is equal to negative 12. All right, quadratic equation, we're not done. We're going to add 12 on both sides so we could set this equal to 0. So now we have x squared minus 10x plus 21 is equal to 0. So at this step now, family, all we need to do is just factor. So this is going to turn into x minus 7 times x minus 3 is equal to 0. And after we set both factors equal to 0, we're going to get x is equal to 7 and x is equal to 3. And just make sure that you plug this back into the original equation to check if any of these are going to be extraneous solutions. In this example now, we're going to start off by adding 5 to both sides. So we're left with radical 3x plus 13 is equal to x plus 5. We get rid of the radical by squaring it because it's a square root. We're left with 3x plus 13 is equal to x squared plus 10x plus 25 after we FOIL that binomial. So we're left with the quadratic equation. We're going to combine like terms, set the equation equal to 0. So we subtract 3x first. We have 13 is equal to x squared plus 7x plus 25. Then after we subtract 13, we're going to get 0 is equal to x squared plus 7x plus 12. So if the equation has 0 in the front, or you rewrite it as x squared plus 7x plus 12 is equal to 0, it's going to be the same thing, whichever one works. So when we factor this now, what we're going to have is x plus 4 times x plus 3 is equal to 0. So that means x is going to be equal to -4, or our x is going to be equal to -3. So let's say we plug this back in now, and we started off with -4. So now we have -12 plus 13 minus 5 is equal to -4. We have the square root of 1 minus 5 is equal to -4. So this simplifies to 1 minus 5 is equal to -4. This is going to be a solution for the radical equation. So x equals to -4 works. Now let's say we did this again and we substituted in our second answer. So we have the square root 3 times -3. So we'll repeat the process. We have -9 plus 13 minus 5 is equal to -3. So when we simplify this, -9 plus 13 gives us a +4. Rewrite the rest of the equation. Simplify the radical to its square root. 2 minus 5 is equal to -3. So we know -3 is equal to -3. So again, we do not have any extraneous solutions. Both of these answers work. And now we're going to go on to the last problem of this video. In the last example, we're going to start off by adding x on both sides. So we're left with radical x plus 7 is equal to x plus 1. We can flip it around, same exact expression. So we get rid of the radical by squaring both sides. We're left with x plus 7 is equal to x squared plus 2x plus 1. Now we start to simplify by combining our like terms, setting the equation equal to 0. And this is what we're going to have after that step. So now we have to still subtract 7. And what we're going to get now, family, is 0 is equal to x squared plus x minus 6. So now we're just going to factor the quadratic. So we know 0 is equal to x plus 3 times x minus 2. And after we set both of these factors equal to 0, we're going to get x is equal to -3. And in the second one, we're going to get x is equal to +2. We really hope that this review on how to solve radical equations was helpful for you, math family. If it was, smash the like button for us, subscribe to the channel, and let us know if we need to make more videos on this topic, or if you have any questions, concerns from this video. Thank you guys so much for watching Algebra 1 with Mr. Peters.